Hello everyone, myself Himani Sharma from IPIT campus. In today's class, I discuss about the iodometry. In previous classes, I discuss about what is the redox reaction, what is redox titration, oxidizing agent, oxidation number, and there in the class iodometry. Iodometry is a type of indirect redox titration that involves the titration of with iodine. It is based on the conversions of the iodide to iodine, which is then titrated. And there are the burette. In the burette we take the sodium thiosulfate and potassium iodate Ki in the flask, and the chemical reactions with the iodine I2 and turns it into the I negative, which is the colorless. First MnO2 is added, next forms the iodine, add some starch, and the iodine is blue with the starch, and the chemical reactions with iodine and turns it into iodide, which is colorless. First is the principle. In iodometry, a standard solution of the sodium thiosulfate and 2O S2O3, it is used as the titrate and measure the amount of iodine liberated from the potassium iodide. Liberated iodine forms a complex with starch, creating a blue color and which help in the indicate the end point of the titration. Procedure. Potassium iodide is taken excess in a flask, and then oxidizing agent like MnO2 is added, which react with the Ki in the presence of an acidic medium H2SO4 liberating iodine I2. 2Ki plus MnO2 plus 3H2SO4 is converted into I2 plus 2KHSO4 plus MnSO4 plus 2H2O. Starch is added as an indicator and forming a blue complex with iodine, and the iodine starch complex is then titrated with the sodium thiosulfate and 2H2O2, and there are which reduce the iodine back to iodine, and as the iodine is consumed, the blue color fade, and when the blue color completely disappear, indicate the end point of the titration. Applications. Iodometry, it is used to measure the amount of sulfur dioxide and other reducing agent in a solution, and iodometry, that is the method to used for determination of both the oxidizing and the reducing agent due to the sensitivity in detecting the iodine. Next is the Cerimetry titration. Cerimetry is the specialized redox titration utilizing the cerium and ion 4 and ion C4 plus as a potent oxidizing agent. It involves the reduction of the C4 plus to Ce3 plus by various reducing agents such as the iodide, thiosulfate as oxalic acid. Principle. The titration is based on the redox reaction between oxidizing agent and the there are the at and the equivalence point number of electron transferred matches stoichiometry. Cerium 4 is a yellow and serve as an indicator. Reductions to cerium result in the colorless solution signaling at the end point. C4 plus E is converted into Ce3 plus. Cerimetry titration. C3 plus is converted in C4 plus is converted into C3 plus, and Fe2 plus is converted into Fe3 plus. Oxidation and reduction carried out. Flask. In a flask we take a Fe3 positive and ceric, and in burette we take the NH4 SO4 to H2O ceric ammonium sulfate. There are the color converted into yellow to colorless solution. In today's class I discuss about following terms like cerimetry titration, their application of iodometry and iodometry, and what is the principle of the iodometry. Thank you for watching.